This podcast, we will go over ionic compounds, and we're specifically going to focus on naming. So how do you name an ionic compound? And we're going to cover both when you have a representative metal that you're naming an ionic compound and also with a transition metal. All right, so we will start with representative metals. So those are the metals that have a single charge. They're your group A metals, so not transition metals with those multiple charges. We always start by naming the metal first, and the metal is always written first in the formula, so that should be fairly helpful. We will then take the stem of the nonmetal. For example, if chlorine's my nonmetal, the stem is chlor, and then we change the ending to IDE. So this becomes chloride. Okay, so let's give this a try. We're going to start here. This is a metal. First thing I want to ask myself, and I know this is going to be a representative metal because that's what the podcast says it's going to be first, but I always want to double check, is this a representative metal, a group A metal, or is this a transition metal? Aluminum is a representative metal. So I'm going to name, that's Miss Jules, she's trying to edge in on this podcast, how dare she. So aluminum, that's a tough one to spell right now. Aluminum is our metal. We don't change anything about the aluminum. And our nonmetal is oxygen. Okay, so oxygen, we're going to take the stem, ox, and we're going to change the ending to IDE. So this is aluminum oxide. If you're feeling confident, you should pause right now, try the next two, and then check in with me to see if you got them right. All right, the next one, we're going to start. That first element is a metal. Is it a transition metal or is it a representative metal? And it is a representative. It is group A. So we'll find out why that's important soon, but I just want you to start saying this in your mind before it gets too tricky. So we named the metal as is. Ca is calcium. And we look at our nonmetal. Br is bromine, and we change the ending to bromide. And one quick note, and I've already kind of goofed this up, is you do not need to capitalize your names unless they're starting a sentence. And I am always in the habit of capitalizing stuff. It's terrible. Let me see if I can do this right on number 3 without capitalizing. Your homework will yell at you about that. It's not a huge issue for your exam, so. All right, again, starting with the first element, K is a metal. Potassium, is it a transition metal or is it a representative metal? It's a representative metal. It has a single charge. It's in group A. So we're going to name that as is. We don't do anything special. It's just potassium. See, I just capitalized that again. Oh, okay, potassium. Second element is O, or oxygen. And oxygen's kind of a tricky one. You're going to drop all but the ox and change the ending to IDE. All right, so naming ionic compounds with representative metals is pretty easy. You just give us the name of the metal as is. You don't change anything. But ionic compounds that have transition metals get one extra piece of information, and that's going to be the charge of that species so that we know if you're talking about iron 2 or iron 3, etc., etc. So with that being said, we know that our transition metals can form more than one type of iron. I gave you that exact example. And so we're going to use Roman numerals in the name to show the charge of that transition metal. So if I was trying to communicate that I'm talking about iron with a +2 charge, I'm going to say iron, and I'm going to put 2 in Roman numerals. Just as a primer on Roman numerals, there is 1, there is 2, there is 3, and here's where it gets kind of weird. For 4, it's IV. 5 is V, 6 is VI. Okay, it may have been a while. We're just going to pretend like we never forgot those. A couple of funky things to know about our transition metals is tin and lead are not in the transition metal category. They're in the carbon family. They're way over by the nonmetals. And they also can either have a charge of +2 or +4. So because of that, we're just going to treat them like transition metals, and anytime you write their name, you are also going to say whether this is lead 2 or lead 4. You're going to indicate which of those two charges it is. As I said in the previous podcast, there are exceptions to this rule. There are a couple that you should know, and silver and zinc are the ones that you need to know for this class. So silver always has a +1 charge, so you're not going to see it written as silver with a 1. Okay, I'll tell you right now, chemists are kind of lazy when it comes to writing, and that is just an extra thing to have to write and communicate when everyone knows that it only has a +1 charge. Same thing with zinc. Zinc always has a +2 charge. Ooh, silver. So that is something to keep in mind, that you may not see that for those, even though they're transition metals, because they don't have more than one charge. Being as we're in nursing, you will still be seeing common names on drugs. So it's important for us to know that you can use common names. So for example, for iron, we've talked about a +2 or a +3 charge. We use an OUS ending or an IC ending to indicate whether it's the lower charge or the higher charge for that species. Keep in mind, that doesn't tell us what the charge is. You have to know that iron has a +2 or +3, so you know what is lower, ferrous +2, versus what is higher, ferric +3. First example, copper is either +1 or +2. You have to know that it's +1 or +2 in order to know what the lower charge is, cuprous +1 versus cupric +2. And these are based on the Latin names. So ferrous, cuprous, which is what the symbols denote from. So if you're wondering why iron is Fe, ferrous, and copper is Cu, it's cuprous, not just people that can't spell, but people who really love Latin. Let's see some examples. Here we have FeCl3. So I want to name this. I'm going to do this the same way I did for representative metals. I'm going to look at the very first element and say, is this a metal or a nonmetal? Fe is a metal. Is it a representative metal or is it a transition metal? And it is in fact a transition metal. So I'm going to name it as is, iron, and I'm just going to leave a space here for the Roman numerals so I don't forget. And I'm going to go ahead and name my nonmetal. Okay, this is chlorine. And we change the ending to chloride. Now, to figure out what goes in those parentheses, I'm going to go back to my equation. Okay, so there is no number here. There's none at all. That doesn't mean that I have 0 irons. It means I actually have 1. We don't write 1. It's assumed you have at least 1 or you wouldn't write the silly symbol. Okay, so we have 1 of those. We have 3 chlorines. We know chlorine has a -1 charge. So the overall charge of my nonmetal is -3. As we will talk about more, we know that the overall charge of my metal then, to cancel that out, must be a +3. Well, I only have 1 iron. What must that charge be in order to get to that +3 to cancel it out? That iron is +3. And those two charges would cancel. So that's how I determine that. 1, 2, 3 for Roman numerals. Do not reverse your drop and swap. That is a bad idea. We'll talk about what a drop and swap is when we write formulas. All right, our next one, Cr. Is it a metal? Yes, it's chromium. Is it a representative metal, group A, or is it a transition metal, group B? It's transition metal. You were supposed to fill in that. I hope you yelled that out at home. This is like Dora the Explorer. Okay, so this is chromium. Chromium. I don't know what the charge is. I'm not dealing with that right now. I'm just trying to name. It is paired with our nonmetal. It is oxygen, so we convert the stem. We keep the stem ox, and we change the ending to oxide. Now it's time to figure out what the heck the charge of chromium is. I know that I have 2 chromiums, have no idea what the charge is. Okay, and now looking at oxygen, I know I have 3 oxygens. I'm going to use that nonmetal and the charge and the amount of those to work backwards and find out what the charge should be for the chromium. So oxygen is a -2 charge, so 3 times -2 is a -6. I know this needs to add up to 0. So what plus -6 gives me 0? +6. All right, I heard you yelling at home. Thanks for trying to make this interactive. I appreciate it. So what times 2 is going to give us +6? That's right. It's +3. Okay, this is getting weird. I got to stop the Dora stuff. It is a +3. So that +3 is actually what our charge is. That's what our Roman numerals should be. So this is a couple examples of ionic compounds that you would find in your home and in your everyday life. And the first one is, let's get that pen working, potassium iodide, or Ki. And potassium iodide, let's see if I can highlight this for you. Boom, right there. Potassium iodide is an ingredient in table salt. So it is actually added to table salt because table salt is just sodium chloride. Iodine is needed to synthesize thyroid hormones, specifically thyroxine. And if you don't get enough iodine in your diet, deficiency can lead to insufficient thyroid hormone production. So your body then tries to compensate and it says, well, you're not making enough of this hormone. Let me make the gland that makes the hormone bigger, and then you'll be able to make enough. And so before too long, you have an enlarged thyroid gland, also known as a goiter. So now I'm not saying go nuts on the salt. Okay, just you have enough salt in your life to get the iodine that you need, but that is why that's there, is to help. It's hard to find iodine in regular food sources, which is why we've just decided we'll add it to something that everybody loves in all their food. Second example of an ionic compound found in your everyday life is NaF, which is sodium, not a transition metal. It's a representative metal, fluoride. And sodium fluoride is added to toothpaste to strengthen the tooth enamel. It also helps to prevent tooth decay. Toothpaste, coincidentally, also contain tin. That would be tin 2 fluoride, and aluminum oxide, which both will act as abrasives that kind of get that plaque and all that gunky, gross stuff off. So good examples of representative and transition metals in ionic compounds that are used in our everyday life.